Alright, let's review vertical shifts of quadratic functions. Let's recall that a quadratic function on a graph is a parabola, so it's got a U shape to it. With the x squared, if it's a positive or a negative in front, that tells us whether it opens up or down. In the case of this graph, we open up. And we want to shift this graph plus 5 units. That means that wherever this first graph is located, our new graph is going to be 5 spaces up from there. I'll go ahead and show you as an example. Now, whenever you guys do this for our quizzes or tests, we're only looking for you to give us the new graph and the new equation. I'm just doing this to show you what it is you're doing. So let me graph this one real quick. So in red, this is our original parabola. So what happens when we shift it plus 5? We talked about how we can just take this 5 and add it to our quadratic, giving us a new equation, y equals x squared minus 1. And that we could graph it using the XY chart we've been using since last semester. Another way of going about it is let's look at it visually back on the graph. So our original graph started down here at 0, -6. That was that vertex. But we've now moved it up 5. So if I count 1, 2, 3, 4, 5 spaces up, that'll be my new vertex. If I do that with each and every point, I'll have my new parabola. So in blue, this is our shift. And all I'd be looking for is that blue parabola and the equation. Now another method, so I talked about the XY chart over there. In order to graph this, you could have just found our new equation right here and then plugged in each of those x values. So we would have -2 squared, which is 4, minus 1 gave us 3. Now if we look over here at our graph, if we go to the left -2 and up 3, that point is on our parabola. Plug in -1, we would get 0. If we plug in 0, we get -1. Plug in 1, we get 0. Plug in 2, we get 3. Alright, so I've just described 2 methods we can use in order to solve these. Whatever method works best for you guys, that is perfectly fine. Again, what I am looking for in your answers is the new equation and the new graph. Let's take a look at this one. So this example is only slightly different from the last. We see that this time we have a negative in front of the x squared, so our graph is going to look something like this. And we see that wherever it starts, we're going to shift it down 6. So let's apply that shift first. If I take the -6 and apply it to my equation, I now get y equals negative x squared minus 1. And because I want to show you guys how to do this in the least number of steps, or just the bare minimum that you need on your paper, let's go ahead and use the x, y chart. Now, many people have struggles with that negative in the front. Whenever you guys are using your calculators, I know I've showed many of you how you can plug it in there just with one string of characters and then hit enter and it gives you the right number. Those of you that don't have just a regular like TI scientific calculator or a Casio, I strongly urge you to get it before EOC, ACT, or whatever else comes up in your future. They're very handy calculators and make this so much easier to do. Not to say you can't do this with your iPhone or your Android, but it makes that negative out front something that you have to be very, very careful of. So let's talk about this one. If we take negative 2 and plug it in for x, and I'm going to go ahead and write this out, we would now have y equals negative. Now I always put whatever I'm plugging in for x in parentheses, because if you don't, your calculator will not apply that square to that negative. If you just type in negative 2 squared into your calculator is reading only 2 squared, and that's why you get negative 4. But we know that if we do negative 2 times negative 2, which our problem reads, we should get positive 4. And that's why the parentheses are important. Alright, so we know negative 2 squared is 4. There's that minus 1 out front, and then subtracting 1. So now negative 1 times 4, we get negative 4 minus 1, giving us an answer of minus 5. Now I'm going to go ahead and do each of these step by step. Many of you have your calculators that'll do it for you. I showed you how you could go over and just edit what's in the parentheses. And that's what I'm going to do by hand. Alright, so now negative 1. Negative 1 squared is 1. Negative 1 times 1, we get negative 1 minus 1. So we get minus 2. Let's edit this. Plug in 0. Well, 0 squared is 0. Negative 1 times 0 is 0. Minus 1, we get negative 1. Alright. So now 1. 1 squared is just 1. Minus 1 times 1, we get negative 1 minus 1. Negative 2. And for 2. Now, many of you may have already seen the pattern that we get with these problems. So, for the examples that we give, now I'm not sure if it's going to be like that on the EOCs, the ACTs, the compass tests, all those ones that we have talked about. But just for the examples I've been giving you, you'll see that at 0, we should start flipping around. We see that now we have negative 2 for both negative 1 and 1. If we get negative 5 for negative 2, many might already predict that we should get negative 5 for 2. And let's test that theory. 2 squared, 4. Negative 1 times 4, negative 4. minus 1 gives us negative 5. So perfect. Now all we have to do is graph each of these ordered pairs. Negative 2, so we start at the origin, go over 2, down 5. Negative 1, so to the left 1, and then down 2. Zero, negative 1. 1, negative 2. And 2, negative 5. And then I just got to connect my dots. Again, guys, please make sure we hit all of our dots, that our graph goes off the grid, and the arrows are on the end. Alright, so I do have 2 more examples on here that I would like you guys, I know you may not have graph paper, but what I would like you to try is to pause it, find the new equation, and just find the values that go in the XY chart. That's always a good exercise to practice, and it's just to make sure you guys are using your calculators correctly or doing it by hand. Either way, it works just fine. So pause the video, apply the shift to the equation, write the new equation, and fill in an XY chart. Then come back and see what the answer looks like. Alright, so check out the solution for this example. I went ahead and also graphed it for you. And then go ahead and try out the last one. Again, pause the video, apply the shift, and fill in your XY chart. Also think about, try to visualize what direction it's supposed to go and where it's going to be placed on the graph. If you can go ahead and get a visualization now, then you're on the right track. You guys will probably be set if you can start doing that. If not, don't worry, we'll get you there. Alright, so check out the last example. We know the graph was going to go up, and we see that our new equation is x squared minus 2, and here's our XY chart. Alright, so I hope this video helps. I know it's a little longer than others, and this has been one that people have had a hard time maybe visualizing or understanding what exactly we were doing. So again, vertical shifts, we're just moving the graph up and down. And then these kind of examples we see in real life. You know, whenever, say we're throwing a ball or something. Well, say if your little brother's throwing a ball and you're much taller than him, and you both throw the ball from the same point, and say they go the same exact shape to their arc. Well, the only difference between it is you're so many feet or inches taller than him. So that might be a way to kind of visualize. It could just be a height difference in what's going on in the example.